Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is this library that we are developing together for JSFX, real-time audio processing in REAPER, which is a digital audio workstation. And today we are going to first fix the presentation of our unit tests that are overflowing the screen. And then we are going to take a brief look at all the data structures we have implemented. There are a few things that I know I want to change, and I guess I'm starting every stream by iterating on this and going over everything one more time just to make sure that I'm happy with what I have. Then we are going to implement circular buffers, and we are going to implement maybe something else like an easy filter to implement, like RBJ filters, which boil down to copying and pasting some equations from different places. So we'll see if we get there. Let's start with the easy stuff, which is the presentation of the unit tests. I tried to fix this yesterday by going to a new line. And that's fair. And if we have like really many tests, I think that that's the only solution. But instead of presenting the unit tests with pass and fail, I'm just going to use a dot and F, which is a common thing for other unit testing frameworks to do. For one thing, I think that RSpec does that in Ruby. And I don't even remember what other frameworks that I actually use, like Jest. I don't even remember what they do. But I remember this from Minitest and RSpec back in my old Ruby days. So if I do just this change, I think that it is short enough that it will fit. We'll see. Oh yeah, absolutely, it does fit. So dots mean success, F means failure, good enough. Let's move on to maybe extracting this. Let's see if it makes sense to extract this into our library. So what this is doing is just, it's receiving the condition that you want to test, and it's printing either a dot or an F. And I think that most of these, yes, I think that this will work, because if you want to change the location where you're printing your unit tests, you can just change JSFX X and Y before you call this, which is actually what we are doing. See? We set the JSFX X and Y, and then we use the assertions. So we can just extract this into our library. And I think it makes sense, because in some cases you will want to maybe have some sort of secret screen in your JSFX where you test stuff. Or maybe this is going to be super specific to this demonstration page. But I don't know. I think it's advantageous to have it on the library. So I'm going to put it there. And I think I will have it below all these things. It needs to be below at least the design system. In case you don't know, this library that we are developing comes with a design system with things like different colors and everything. And we are using some of those in the assertion library, so we need to put the assertion library after the design system. There are these drawing functions. I guess I'll just put it here. I'll say that this is the unit testing or assertions. Yeah, whatever. Unit testing. Assertions. No, just unit testing. And that's just the code that I cut from the other file. And I think that this is just going to work out the same when I reload. Yeah, there we go. Nothing changed. So we can commit this, and then let's move on to the review of the existing data structures. First of all, I have these magic numbers to represent ideas that don't exist in JSFX. There is no notion of undefined variables and no notion of error handling. So I'm just picking special values that I hope you will not use. But I don't like these special values, so I'm going to change them. So I'll have something like 9, 9,000 and 9,001, and I just hope that minus 9,000 is not something that you actually use. So I'll sort of do an enumeration, but in a weird range, starting at minus 9,000. It doesn't really change anything, it's just a matter of preference. I rather have these numbers going up, and I don't believe I will have more than 100 of these special situations. Next, we have memory management. One thing that I'm trying to do with the data structures in this library is to make everything memory safe, because in JSFX there is very little structure to the use of memory. So if you write something that is incorrect, you will overwrite some other pieces of memory and end up in a bad situation. If you use my library and my data structures instead, you will at least have some notion of error when you try to index an array that is out of bounds. Now, in order for this to work, I need to have this global variable that is the current position where I can allocate more memory. And I believe that this name no longer makes sense. Before, we had more functions that had to do with memory. We had memory stars and end, and you can watch previous streams to understand what I'm talking about. But right now, we just have allocate. So maybe I can change this to just be allocate, or memory allocate, or allocate memory. Yeah, I think I'll call it, or maybe instead of calling it memory allocate, it is allocation, but I could give this a different name, like memory chunk. Usually in C, this would be malloc for memory allocate. Or maybe just memory. Yeah, I think I like this. And then let's go here and do the same change. It's only this location where we are using allocation. So there you have it. Now it's just called memory. And then let's briefly review this. We get the next address that is available. We increase the next address that is available by a certain size, the size that we are allocating. We are setting that memory to undefined to begin with, and then we return that address. For enumerations, I think I also have a renaming that I want to do here. Right, because I used to have, again, go watch the previous streams if you want to learn more about this, but I used to have enumeration defined and enumeration constant, but right now I just have enumeration constant. So I think I'll just do something like this. And of course, here I have to change that as well. And I think it's smart for me to check that all the tests are still passing. Yeah, everything is all right. We are just renaming stuff. Didn't break anything yet. Then we have the notion of boxes. A box is just one item in memory, and you can write and read from the box. Very simple stuff. Why do I have this as a set of functions instead of just accessing memory directly? Well, for two reasons. First is you have to use this weird syntax to access some address, to dereference the pointer to that address in memory. But also I like the name. I think that box is a good name to represent this idea. And I think it's a name that I borrowed somewhat unconsciously from Racket. Yes. Minimal mutable storage, single element vector, that's exactly what I'm doing. So that's where the name came from, in case you're curious. So we have a setter, a getter, and new. And new, usually I would define first, but it's using the setter to initialize with a certain value, so I am putting the setter and getter before new. And then the business here is similar to this one. I just allocate some piece of memory, I set the initial value, and I return the address to the box. Notice that I am setting the value on the box, but I am... Baby's here. I'm setting the value to the box, but I'm returning the box address, not the value. And that's super important. When you're using the box, you need to get a hold of the address of the box, not the initial value. And IDDQ sound is here and says, E aí? E aí? Beleza? Great to have you here, Arya. All right, so that's what boxes are. Then we go to structs. Structs are more difficult and interesting. A struct is a variable that you can subdivide. That's one way of thinking about it. Again, I think it's a name that I borrowed from Racket. That's how I best understand structs, but they exist in C and C++ as well. So a struct is just a chunk of memory that you index by name. That's what this is. And then I need a global notion of what is the current struct that I'm defining. And then I have these functions called define to start the definition of a struct. And then I just allocate a box. This box is going to be the size. And the size of the struct starts with 0 because there are no fields, 0 fields in the struct. And then there is this struct field. And I think I'm going to rename this as well. I think it's going to be define __ field. And I'll do the same over here. Right? Because it's part of the definition. It's like a sub-function to this function. And then the business that I do here, again, super similar to what we did in other cases above. I just get the current index that is available. Each field will have an index starting with 0. That's why this 0 is there. Then, so I get the value in that box, which is the current field index. Then I set the value to the box, which is... Oh, I'm doing that in a silly way, aren't I? Because I'm doing this whole bit while I could be doing that. And then I return that field index, which is important because when you're defining a field, you need to have that index so that later you can refer to that field. Then, so that's how you define a struct. Now, to create a struct using that definition, you need to call this function and you use and you pass along the struct definition, which remember is just a box with the size of the struct. There is nothing fancy about this. Then I get a hold of the size and I create a structure by allocating some memory. I'm going to allocate 1 for storing the size of the struct in the struct itself so that I can do bounds checking. I can check if you are trying to index into the struct correctly. Again, memory safety, a big thing in the data structures in this library. But I also, of course, have to allocate the number of fields that you are going to have. And I initialize, so this position 0, which is the size of the struct, I initialize with the value that I got from the box, which is the struct definition. Then I have 2 auxiliary functions that will be used below for the setter and getter. The first is to check if the field is valid, and I just check if the field is less than the struct size. And then I calculate the field index into the struct by just adding 1. So remember, this first position is where we are allocating the struct size plus the field, which starts at 0. So yeah, that's very easy. The field is just a number that indexes into the structure. Then to set, I check if the field is valid on the struct and I return an error if it's not. Otherwise, I set to that position. And then similarly here, I just get the value from there. I was thinking that maybe there was something else that I wanted to do with this, but I forget, so yeah, it's probably fine. So I'm going to commit these changes and let's check if I broke something. No, everything is still passing. Then we have arrays. And arrays are a block of memory that you index by number. A struct you index by name. An array you index by number. And the big thing about the array, instead of just getting a chunk of memory, which you could do, you could use memory to do that. But instead of just using a chunk of memory, the array is going to give you bounds checking. If you try to index outside the array, you get an error. So let's see how we are defining an array. Well, first of all, I have this variable name that I don't like. I'm going to just call it that. And I have this convention that L__ means private. It's something that I need internally in the library, and you as the developer using the library, you should not touch this. Now, this other convention is that structs start with struct__. This is something that I expect you, the user of the library, to also follow if you wish. And that's the definition of the struct, not an instance of the struct. You can think of this as like the instructions to create a struct, if you will. Then I start the definition of a struct, and I have two fields on this struct. So this is already an example of how to use structs. The fields are the size and the values. The size is exactly what you would expect. It's just a number. The values is a pointer to a chunk of memory where we are going to store the values for the array. To create a new array, you just have to give me the size, and I'm going to do the similar trick to many of the functions above. I'm going to create some data structure, I'm going to initialize the data structure, and I'm going to return the address to said data structure. So I'm going to create a new one of these arrays data structure. I'm going to set to the size a certain size, and to the values, I'm going to allocate a chunk of memory. So as I said, internally, an array is just a chunk of memory. I'm just storing the size as well so that I can do bounds checking. And Aria asks, so the sizes correspond to a width and height value? Well, not quite. An array here is just a data structure. It's just a block of memory, and the size is the length of that block of memory. So if you have an array with, let's say, 5 fields or 5 numbers, you can index from 0 to 4. This size is the number 5. And I store this information so that if you try to index into position 17, which does not exist in an array of 5 positions, then you get an error back instead of indexing and getting some garbage value from somewhere else in memory. But a size is not a width and a height. A size is just the length of the array that you are allocating. And naturally, if you had an array to represent, maybe if you have an array of arrays, which is a matrix, if you have a matrix, which is maybe something that we may want to implement. But if you have a matrix, which is an array of arrays, and you are representing with that matrix like something on the screen, then maybe the size could be a width and height. But that's not always necessarily the case. And Bo is here saying, hey guys, hey Bo, great to have you here. And I hope you're doing well as well. Okay, so what do we have here? Okay, so I again have one of those auxiliary functions that I need to check the bounds. So given an array and an index, I check if the index is less than the size. And now you can see that I'm starting to use data structures to define arrays, and I'm going to use arrays to define circular buffers It's a whole thing. And then to set and get values into the array, I have to have the array and the index, and in the case of the setter, the value as well. And this looks a lot like the struct. I just check if the index is valid, and I error if it's not valid, and then I get the values. Remember that the values is just a chunk of memory, and then I can index into that chunk of memory and set the value or get the value from there. So nothing fancy on this part. Okay. It seems like Bo and Aria are collaborating on something. What are you up to, guys? And this is just renaming, so no big deal as long as the tests are still passing. And they are. Next, let's talk about circular counters. And you can imagine that circular counters are going to be a fundamental part of circular buffers, which is what we are going to implement today. So a circular counter is a number that you can step. So maybe you start, in our example, you start with the number 10, and you can step to 11 and 12 and 13, and then you wrap back. So maybe at 15, you wrap back, and then you start stepping again. That's what circular counter does. And of course, it's going to be important for indexing into the circular buffer, but it's also useful for doing things like an oscillator. We'll probably revisit the oscillator that I developed as part of my tone generator, and we'll probably use the circular counter to do that. We'll see. Right now, I know that I don't want this definition suffix. So getting rid of that. So same as here, right? The struct array is the internal definition of what an array is, and the circular counter is the internal definition of what a circular counter is, and a circular counter has a bunch of fields. The current value, the initial value, because you are able to reset. Oh, and I just remembered something. So I'm going to commit these changes. Hopefully the tests are passing. And I'm going to return to arrays because there is something fundamental about arrays that I forgot to implement, which is the array size. And of course, that is just returning this field from the struct, but it's important to have that. So maybe I will implement this here because then I can use that there. So I'll define a function called larray size. And this is just that. And then I just call this function from there. And I will add to the tests something to test that. Yeah, so these are my tests. I'm going to assert that larray size of coefficients is equal to 5. Oh, and that test is failing, so what's up with that? Did I set a different size for the array and I'm not? Oh, the size of the array is 4. There you go. Yeah, the size of the array is 4. There you go. Now, and why do I think that this is fundamental? Well, because in many cases you want to iterate over the array. You want to do a loop over the array. So you must know the size of the array. Okay, let me catch up with chat. Then I'm going to continue the explanation of the circular counter, and then I'm going to revisit the tests. I think there are some things that we can simplify over here, and then we'll move on to circular buffers. But first, chat. Let's see what you are all talking about. Oh yeah, literally 30 minutes later and they have been gone. Yeah, Bo did awesome vocals on my new album. I did not know that you were working on a new album. Huh. What message did you get in Swedish? It was a whole email in Swedish. Okay. Okay, question. So the struct works similar to free mem? Like I have a chunk of memory for my UI and one for the delay buffer and etc. Yes. So free mem is in JSFX. There is this function that comes with REAPER, free mem, and it's a hint to REAPER that you are not using memory from that point on. And we are not using this actually. It's a good practice to use it, but for various reasons that we covered yesterday, I don't think that we are going to use this in our library. But yeah, you can have a chunk of memory for some of the data structures, like some of the structs and arrays, and then another one for a delay buffer, which is actually interesting. Probably we want to implement something like a delay line, which is similar to a circular buffer, but I think there are some twists to a delay line that may warrant a custom definition, a custom data structure for that. Weird, I wrote to you in English. Was the message from Spren in Swedish? Okay, I'll let you guys figure this out. So let's talk about circular counters. A counter has all the fields I mentioned, the current value, the initial value, because I want to be able to reset the counter. Then a start position, an end position, and a step. And this is like you start at the number 10 and you go from 10 to 15 and with a step of 1, for instance. So it goes 10, 11, 12, 13, 14, 10, 11, 12, 13, 14, and so forth. Okay, so to create a circular counter, you give me the initial value, the start and end and step, and what I do is I just allocate that struct, and then on every field I put the initial values there, and start and end and step, and return the address for that for you. To reset a counter, I just set the current value to be the initial value. And I wonder if I should have getters for these fields, like the size in the array has a getter for the size itself. I wonder if I should have getters for these guys, but maybe this is like too much. This is in the array, it makes sense to iterate over the elements, but in a counter, if you're starting to iterate over the counter, I think you're misusing the counter, so I'll not have that for now. Then to step, give me a circular counter, and I will get a hold of the current value from the counter, and the start and end positions. I'll calculate the range, which is just the end minus the start. And then I'm going to increment with the step. And then I'm going to check if the current value is greater than or equal to the end is not inclusive. So if the current value is equal to the end, then I should wrap back by subtracting the range. Similarly, if the current value is less than the start, then I need to increment the range. So your step can be negative, and then when you add the step, you end up below the start. This fixes that, so we are always in the range. And then I set the current value to be whatever I calculated. Now there is an issue here, which is when I'm creating the counter, I don't check if the start and end make sense. So yeah, I guess let's do that. If this step is equal to 0, that's a mistake. CircularCounter needs to increment or decrement. Or there is this situation in which this step has a sign that is negative or positive. So let's check this out. How do I get the sign of a number? Yeah, okay, so sign is going to return -1 or 0 or 1. So if the sign of the step is 1, I will even say +1. If the number is positive and the star is greater than or equal the end, that's a mistake. Or if the sign of this step is negative and the star is less than or equal to the end, that's also a mistake. Let's think this through. In both cases, if the start is equal to the end, that's a mistake. Because how are you going to step if you have no space to go? You have no place to go, right? If the range is 0. And then if this sign, and maybe I could have some checks on the array, like the size of the array needs to be positive and whatnot. But I think that maybe I'll do that. Yeah, maybe I'll do that. We'll see. I guess I'm going to leave like a buffer here with a to-do, like check for negative sizes, whatever. But more importantly, if this is the case, then I return an error. I cannot create a CircularCounter that way. Otherwise, I do the whole thing we had before. Okay. Just quadruple checking this whole thing, and I think it makes sense. I'm now doing the right thing here. And I have some tests that I said that I would write today. So we're going to do that as well. Let's leave this note here, and yeah, I think that all the changes I made don't affect the tests. We'll see if the tests are still passing. They are. So let's do the bounds checking or the size checking for everything else. Let's see what makes sense. The size needs to be, when you're trying to allocate memory, the size needs to be greater than 0. So if size is less than or equal to 0, I'll throw an error. I really wish I could throw an error. No, I can just return the error variable. Then enumeration doesn't have any conditions. Box doesn't really have any conditions. Structs have a condition here. Yes, if you try to create a struct that is 0, of 0 size, that does not make sense. So I'm going to say if the size is equal to 0, error. And I think that all of that is okay. Then arrays, similar story. The size needs to be at least 1. How did I do it here? Oh, I made a mistake. Yeah, okay. My struct will start with 0 because of this. So I can just check for the 0. But the memory allocation, yeah, less than or equal to 0. And then the circular buffer, we already did all the checking. Okay, Now this I want to, so effectively we checked for negative sizes. We still have to write tests for those, but I want to double check the diff before I commit. So when allocating memory, you need to have a size that is at least 1. And I could also check for things like fractional values. The size needs to be an integer, but I think at that point I'm already defensive enough, and I'm happy to stop here. An array needs to be it needs to have a size that is at least 1. Yeah, okay, those are the tests. Now, those are all the data structures we have so far. Let's go to the tests and review them. So memory chunk, I think I'll call this just memory. And then we have an enumeration here for the page. Maybe I'll have my memory allocation right after that. Then I have an enumeration example here, and I think that this I'm not even using. That I'm using in one place. Yeah, maybe I'll have just an example here of these two enumerations, and I don't think I have compressor anywhere. So in the init block, I allocate memory, for instance, with the enumeration stuff, but then it's in the JSFX block that I actually run my tests. So let's look at the memory definitions or the data structure allocations alongside with the tests on them. So if I try to allocate some memory, that works. And I can even assert things like this. And I have to use the JSFX native construct for accessing memory because this is just a raw piece of memory that I allocated. But I can also assert the error cases. So I assert that if I try to allocate memory, which is absolutely something you should not be doing in the JSFX block, but I'm going to give it a negative value or even 0, and that should be an error. So that's fine because it's not going to really allocate memory. But if you try to really allocate memory in the JSFX block, you will be allocating memory 30 times a second. It will be a whole mess. You will run out of memory. Okay, so the memory stuff is good. Then let's see if the tests pass. All right. Then we have the filter type situation here, and I don't really like the way that this test reads. I think that we should just check that the low pass and the high pass should not be the same. Is this going to pass? Sure thing, it does. Let's commit what we have. Next we have box, and my box is called a counter. I don't like that name. I think I'll just have the name box. So here I will rename, and I won't rename globally as I usually do because I have the CircularCounter situation, so I'll just call this the box. And those are the tests for the box. And I think that covers everything, but we can double check by looking for counter. And yes, all the other references to counter are in the CircularCounter. Let's test if this is passing. It is. Next, we have structs. So we have a struct coordinate, x and y. And then we define a label position, which is a coordinate. Well, I guess I'll call this the coordinate. And then on my tests, I set, and I try to set outside of boundaries, and I get, and I try to get outside of boundaries, and all of that is passing. Then I'm going to assert that when I'm trying to define, This is going to assert, well, I'm going to assert something about a struct that is empty. Well, in other words, I defined the struct, but I never put any fields in there. So if I try to L struct new on this guy, I should get an error. Let's see if these tests are passing. Yes, they are. Let's commit what we have. So let's go over this again. Memory, I checked for negative values. Enumerations doesn't have any sort of bounds checking. Boxes don't have any sort of bounds checking. Structs, we checked that if you have an empty struct, you cannot allocate it. Then array, that's up next. So we have a new array situation here. And I'm calling this coefficients. I don't like that name. I'm going to just call it array. And I think that in this case, it does make sense to have like a real example, which is a coordinate, because otherwise it would be just too boring, like field 0 and field 1 of this struct. Yeah, right. So yeah, we have an array, and let's go to the tests for the array. I'm checking the size of the array and I'm setting some values. I'm trying to get some values. And I will also check that if you try to create an array with 0 slots, that should be an error, similar to the struct empty or even the memory with 0 slots. Let's see if the tests are still passing. Yes. Next, well, let's commit what we have. Next, we have a CircularCounter. It starts at 13, goes from 10 to 15, and its step is 1. So I already have a bunch of tests for this. I can reset and I can step. But there are several things that we still have to test about CircularCounters. We have to test these error conditions. So let's do that. If I have, well, if I try to create a new CircularCounter with, how about the initial value not being in the range? That should also be an error, right? Yeah, okay, so let's make that an error as well. Or if my step is positive, it means that my initial value needs to be greater than or equal to the start. And if it's not, that's an error. Or it's also an error if my initial value is greater than or equal to the end. Now we just copy and paste this and flip the values, flip the operators, and that should be right. Okay, so if my value is positive, if my step is positive, then I suppose I can do all of these conditions in, I think there is a better way of writing these conditions that will make more sense. Let's see. Okay, so if my step 0, that's an error. If my step is positive, and it is the case that my end, it is the case that my initial value, oh, here's what I'm thinking about. You have your start initial value and end. This is what I want to write. This is what I want to assert. So I guess I will just put a negation here and I will break these conditions apart. So if my sign is positive, my step is positive, and it's not the case that my start is less than or equal to value and my initial value is less than the end, that's an error. So yeah, I think that this logic is right. I'm going to copy and paste it over. But of course, I need to flip these. Yeah, I'm not even gonna think this through. I'll just write tests for this because I think it will be right. So let's do a full compile reset situation here and look at the data structures. Yes, everything is still passing. Let me review my changes. Okay. Cancel this. Oh, I did not save this. So if I'm trying to create, I'm going to comment this out. There are several error cases that we need to test. Okay, catching up with chat. All right, so let me go over this one more time, write some error situations here and some tests for circular buffers that are fractional or that step down. Okay, just a bunch of tests to write, and then we can move on to the circular buffer as promised. We may not get to filters, we'll see. So if my step is 0, that's an error. Or if my sign is positive and it's not the case that my start is less than or equal to the initial value and that the initial value is less than the end. And then over here, I just flip everything. If the sign is negative and then I flip the orientation of the operators, and that should be correct. That should hold water. Yes. Yeah, so let's write some tests for this, guys. First, error condition. If, well, I guess I need some dummy values here. So my initial value will be 0, my start will be 0, my end will be 10, and my step, or maybe just 4, and my step will be 0. That should be an error because of this condition. All right, next. If I have a step that is positive, but my start, so my initial value is out of range, so my initial value is like -1, it fails the start condition. So that should be an error as well. Let's see. If the tests are still passing. There you go. Now let's do the opposite, where my initial value is out of bounds because it's above the end. That should be a problem with this condition. And I will fast forward this. If I have a step that is negative, then I need, well, let's say that I'm just going in the opposite direction. I'm going from 4 to 0, and then -1 should be out of bounds on one direction, and 4 should be out of bounds in the other direction. So all these tests should be passing. Oh no, the last one is not passing. So let's think this through. Oh, it's not inclusive on the other direction, right? So actually what I want to say is from 3 to -1. Yeah, or maybe I'll just change this value. So this is below the end. I can just say that this is 0 because it's matching the end, so that should be out of bounds. And 4 is okay. 5 is not okay. All right. And then we write some tests for circular buffers that are not integers and that step down, negative steps. So I guess I will have to rename this circular buffer to something like CircularCounter. I have to rename this CircularCounter to CircularCounter positive. And let's see if this is still passing. Just renamed, but who knows, maybe I forgot one. Okay, that is all right. In the same way that I have a positive one, I'll have a negative one. And I will have a fractional one. So the negative is going to have a step of -1. It is going to go from 15 inclusive down to 10. And the fractional will go from, it will start at 2.5 and it will go up to, it will go from 2 to 3 in steps of 0.1. Okay, I'm going to split the screen so we have these numbers up there as we are writing the tests. Now here I can reset, I must reset. So let's do this stuff with the negative. I need to reset because my JSFX is running in a loop. So I need to reset the counter to actually be able to test anything. So it starts at 13. Then when I step, it should go to 12 and then 11. And then it should not go to 10 because that's not inclusive. So it should go to 15 and wrap around. Then let's write the tests for the fractional one. And I'm not sure that this is going to work because there is a chance that floating point errors will creep in. Especially because I am adding 0.1, which is a value that cannot be represented in binary precisely. It's a repeating fraction in binary. Yeah, we'll see. We'll see if this works. So as we reset, it should be 2.5. And maybe I'll make this smaller so it wraps around sooner. So let's say that it goes from 2 to 2.7. So it should, when I increment, I'm doing 3 steps and it wraps around. So it should go to 2.6, 2.7. So let's say that the bounds are 2.8. And then it should wrap around to 2, let's say 2.1. Why not? So there will be some noise due to floating point operations, but maybe Reaper will do denormalization for me and will fix that. Maybe, we'll see. So yeah, it goes from 2.5 to 6, 7, wraps around because the end is not inclusive, goes back to the start, which is 2.1. Yes, let's test this. Okay, some of the tests are failing, probably because of floating point mistakes. So how about we do a proper floating point comparison by saying that whatever is there minus this, and we take the absolute value of the result, should be less than 0.01. 001. There you go. That's how you test floating points given a margin of error. Is this going to fix the test? No. So let's see. I'm going to commit what I have because I think this should be right, and I'm going to start writing some debug code. Maybe I can put this window up, and this can be next to me. And then we can go below and we can check what is the value of stepping. It is 2.6. So let's check. Maybe this is not the test that is failing. There is now one more test. There are more tests that are failing here. That is weird. No, I'm confident that these are the tests that are failing. So now let's check. The thing is claiming that it's 2.6. Let's check that it's 2.6. Debug should be 1. It is 2.6. Oh, now more tests are failing because I'm stepping. And as I step, all these are off by 1. Oh, okay, so maybe the tests that are failing are not even these ones. And maybe if they're not these ones, I can get rid of this part. Because yes, JSFX were protecting me from the floating point mistakes. Yeah, that was correct. So let's count. Well, that's, I guess, an unfortunate side of my assertion library. I have to count the dots to know which tests are failing. Or maybe I can just comment some of them out. Okay, so the 3 tests that are failing are the negative counter. These 3 tests are failing. Okay, I know which tests are failing, so I can go back to this situation, and then I have to debug this. So let's see. First of all, if I have like the basics right. When I reset the negative counter, it goes to 13. That is correct. And then when I step, it should go to 12, but it's not going to 12. Then it should go to 11, but it's not going to 11. Then it should go back to 15, and it's not. These 3 tests are failing. So let's put a debug there. And we'll check what this is actually stepping to. It should be 12. It will be something else. That's a huge value. I wonder if there is some mistake in the part of the code that wraps around. If it should have some special treatment for negative bounds. Yeah, let's go to the library real quick. And we are wrapping around in these 2 locations. And yes, I think I need to have a check for the sign of the step. Yeah. So for that, I will have to extract the step because I'm only using it in one place now, but I will use it in, I think, 3 places. So I have the start, end, and range. And I'll have this step right here. Maybe there. And I think that the range still makes sense in the end minus the stars, but I have to think this through. This is actually getting complicated for me. I'll have to like work through the example by hand probably. Okay, I still want to add this step. That much I know. How do I calculate the range? Well, the range in this case is the end minus the start, so the range is -5. Having a negative range kind of messes with my head, but I think it is correct. So I just have to check the sign of this step. And over here where I'm using this step, I can just use this step like so. And I guess I'll also have I'm wondering in which order I should do this. I guess I will do it like this. Okay, and I will need the step sign. And over here, I will check if the step sign is equal to plus or minus 1 and yeah, let's work with the +1 condition first. I think I will need more space between these things. Okay, so let's work through the positive case first because it's easier. I think that the positive case is already implemented actually. This is all there is to the positive case. Or if the step sign is equal to -1 and I think I just have to flip the things, but I'm not even sure. Yeah, so if the current value is something based on either the start or the end. And I just have to work through the logic to find the right operator here. So if I'm going down and my value is less than or equal to the end, and if I'm going down and it's greater than the start, I think that's how you do it. I'm just going to run the tests and we'll see if I got it right. Probably got it wrong. Nope, I got it right. Excellent. Let's commit what we have and I will work through the example by hand because I'm not like 100% confident that I got everything right or if there is like a better way of doing this. Yeah, everything seems to be okay. Let's work through this example by hand. So my initial value or my current value is 13. And my step is -1. So current value 13, start. Now that I committed, I can even do things like this. I can start messing with the code. So my current value is 13, my start is 15. My end is 10. My range is n minus start, so -5. And then my step is -1. my sign is -1. And then my current value becomes, well, it's 13 minus 1, 12. And then if my sign is negative, which it is, and my current value is less than the end, less than or equal to the end, I need to current value, which is, in this case, it's not going to fire. So that's okay. Now, the next time around, the current value will be 12. Current value will be 11. That will also not trigger anything. The next time around, the current value will be 11. And then the current value will turn out to be 10 at the end after I plus this step of -1. So in this case, the current value is less than or equal to the end. And in that case, I subtract the range. So the range is -5. If I subtract the range, I go back to 15, which is my start. And then just flip the logic for the other one. So yeah. Okay, so I tested circular buffers that are not integers and that step down, negative steps, done. Awesome. And I think I tested all the data structures that I have so far. And everything else here is just the color screens. Let's take a brief look at these guys. All right, yeah, I'm happy. Now let's do a circular buffer, shall we? I will need a private struct to be my circular buffer. And it will have the following fields. It will have an array. It will have the current index. Or maybe just this a circular counter. Yeah, let's take a step back and define some tests for this so that we can understand the API that we want to use. So a circular buffer will be a data structure that expects a size and that's all, I think. Just the size. Now let's write a couple tests for this. So I'll assert that when I circular buffer set a weird number, that will be equal to that weird number. And if I try to get, then I think I need to say like how many samples ago. I'm thinking about a circular buffer being used for sampling, like storing samples, then doing stuff to chunks of samples. So I think it's advantageous for me to have, first of all, I will need to say which circular buffer I'm acting on, right? But also, I think I need to say something like, how many samples ago do I care about? So, for instance, if I go 0 samples ago, that's what I end up having. And how about we have a couple of them? I guess my circular buffer has a size of 10. So maybe I will decrease this to 5, and I will do 5 of them. Okay, this is starting to wrap, so let me go there and try to get it out of my face. Okay, so this way I populated. My circular buffer has 5 positions, and I have here 5 positions. So at this point, I filled in the circular buffer. So I can start querying the circular buffer from like samples ago. So if I try to get position 0, it should be this. If I try to get position -1, it should be that. And if I set a new one after this, then oh no, hit the wrong keyboard shortcut. Silly me. Yeah, okay. So as I said, I expect all the values to be like 1 off. Position -1, for instance, goes from 1003 to 1004. And very importantly, if I try to get something greater than what the capacity of the circular buffer, I expect an error. Similarly, if I try to create a circular buffer of a size of 0, then I expect an error as well. I think that's how I want to use it. When you have the time, Leandro, could we talk some more about the pre-ringing in FFTs? I don't know much about this, but we can definitely talk about it. Yes, ask away. Okay, just double checking that my tests make sense. And I'm not sure if I want to have these numbers as negative. I think it makes sense because if you're thinking of indexing, you're like going to samples ago. But then you are forcing the thing to always be like negative, which is like weird from an API's perspective. And even doing something like position 1 should be an error as well. Yeah, I think I'm gonna stand by this for now, but yeah, we'll see. We'll see if we like this. So let's implement this. We are going to need we're going to need this function. And then we are going to need this and that. Bo is asking, I've never heard of that. Is it a PDC delay that's creating it, or... are we talking about the pre-ringing in FFTs, or are we talking about circular buffers? Have you never heard of pre-ringing in FFTs? I don't think so, because you just talked about pre-ringing in FFTs. So is it a PDC delay? So PDC stands for plugin delay compensation, and it is when your plugin needs to get a chunk of signal and process it. So the response of the plugin will be delayed a little, and you can set the PDC, the plugin delay compensation, and then Reaper is going to say, oh, okay, I know that you need a delay of 1,000 samples to process something, so I'm going to ahead of time give you 1,000 samples, and then I'm going to shift your result by 1,000 samples. So that's what PDC is. Oh, so you're asking if the pre-ringing in FFTs is a problem that is related to plugin delay compensation. No, let me try to get my head straight around this. What the hell? So if you're doing FFTs, you need a block of samples. You cannot ask, an FFT is going to go from the time domain to the frequency domain, so it's going to give you the frequencies that compose a certain signal. And if you just have one sample, what is the frequency of that sample? That's not a question that you can ask. It doesn't make sense to ask this question. So you need a block of samples and send that to the FFT. The FFT is going to check the frequencies that compose that block and return that to you. Now, to have a block of samples to send that to an FFT, you probably will need to delay your output. You collect some input, and then you send it to the FFT, and then you do whatever you want to do, and then you output whatever signal you want to output. But in this interim, you are delaying the signal. So if you want to do some sort of FFT, you probably want to do plugin delay compensation, so that the DAW can keep everything in time. But the problem of pre-ringing is not exactly related to this property that an FFT needs to work with a chunk of audio, with a block of audio. These are separate independent problems. The pre-ringing of FFTs is that FFTs by themselves are not going to cause any pre-ringing. If you just do an FFT and then an inverse FFT, no pre-ringing, because an FFT is what is it called? A structure preserving transformation? I forget the proper name for this, but an FFT is a lossless transformation. Everything about the signal is captured by the output of the FFT. So when you do an inverse FFT going from the frequency domain to the time domain, you haven't lost any information in this round trip. You can go from time domain to frequency domain and then back. No information lost. You get back exactly the same signal that went in the FFT to begin with. No loss of signal in the first place. Awesome. Okay, so what is this pre-ringing about? Well, most things that you would want to do in the frequency domain, you are optimizing for the frequency domain. So for instance, if you're trying to do a filter or some sort of EQ, you are trying to separate frequencies. You are trying to attenuate some frequencies and boost some other frequencies. So you are optimizing for the frequency domain. You want the frequency domain to be as close as possible to the filter that you care about. So if you want to cut everything below 5,000 hertz, you want that frequency to match as much as possible what you are aiming for. But there is a trade-off. If you try to optimize for a good frequency response, you end up with a bad time domain response. So that's what we call ringing. If you have like a step function, you can think of like just a signal that is always 0 and then it steps up to just once. Then if you try to optimize for the frequency domain so that your filters are going to filter out the frequencies that you don't want very well, you inevitably are going to affect the time domain. You are going to cause ripple in the step response. It's going to, instead of being just like a step, it's going to ripple and then it's going to go up and ripple some more. And there are techniques to try to reduce that. And there are filters that are optimized for the time domain so that you get less ripple, but the frequency response is not as good and you don't filter out the frequencies that you care about as much, but then you have no ringing, which may be advantageous in some cases. So yeah, plugin delay compensation is necessary for doing FFTs because you need a block of audio to do FFTs. And FFTs by themselves don't cause any ringing, any distortion, any sort of issue because it's a transformation that is preserving all the information. But most things that you would do in the frequency domain are going to affect the time domain, including pre-ringing, ringing in general. It's related to this thing called the Gibbs effect. Gibbs phenomenon. And oh yeah, so here's a good illustration of what I was talking about. So this is a square wave. So you can think of this part as a step just going up, and you can see the ringing before and after. And it's just an artifact of how frequency domain filters work. That's as much as I can tell you. If you have follow-up questions, then I'm happy to answer them. Let's try to finish this circular buffer situation in the last 10 minutes. So to create a new circular buffer, we are going to have a local variable that is the circular buffer. And we are going to check that the thing even makes sense. So if you have a size that is less than or equal to 0, then return an error. Do I have tests for that? Yes. Otherwise, then allocate this struct. So my circular buffer is equal to L struct new of that and L struct set of the circular buffer and the array situation is a new array of size given by the user. And I am going to create a CircularCounter, and I'm going to borrow this so I remember all the variables that I need to pass. And the counter will have an initial value of 0, a start of 0, an end of size, and a step of 1. Then to set a value, I am going to L array set on, well, I need to get a hold of the array. And then what position am I going to use? Well, I can just get a hold of my CircularCounter. So this is going to be long. And what value do I put there? This value. Yeah, so what array am I manipulating? My array from my circular buffer. What position do I have? I want to use this position, and then this is the value that I'm going to put there. And then I'm going to increment my CircularCounter. Oh, I'm forgetting something, right? I'm getting a hold of the array. but here I should also get a hold of the current count. So let me go back to this. Oh, I just want to step. So let me get a hold of this. And then what is this? The circular counter that I pass? This one. And it will also increment the counter for me already. So I think that this is all I have to write. We'll see. And then to get a value, I'll have to do some checks. I'll have to check that the index, if the index is less than 0, or actually greater than 0, or if the index is less than minus the size of this array. Well, I think I'm going to need the array, so I'm going to have a local variable with the array, and I'll get a hold of that array. So if the index is greater than 0, or if the index is less than the size of the array, the negative size of the array, I think it should be, so the size of this array, for instance, the size of this circular buffer that we are creating for testing is 5. And the maximum index I can go to is 4. If I have minus 5 minus the size, that's a mistake. Okay. So what do I do next? I just array get of my array in position minus index. No, that's not how I do it. I will have to have the circular counter. I will have to get a hold of the circular counter, so I'll need some extra functions in the circular counter to get the current step. Yeah, let's see. Sorry, my feed died. I'm watching it back again now. Thanks for the explanation. Gonna check the Gibbs phenomenon. Sure. I hope that helps. Yeah, okay, so we only have like a couple minutes, but let's see. I think I'm gonna comment out everything about circular buffers, because I know that I will need an auxiliary function that I don't currently have. And in the demonstration, I'm going to comment out everything about circular buffers. And as I do this, all the changes I made are now commented out. All right, so let's commit this, and the test should be passing. I'm going to check again for good measure. All right, and then I'm going to write the function that I need, which is to maybe I'll write it down here. I will just circular counter, and I'll call this peak. And what this does, maybe not peak, but current value. And this is what it does. Just returns the current value of that circular counter. Now let's write a test for this. And I'm going to write it after step. Oh, but then I need to check what is the last value in the current positive. It is 11, so I'll say 11 here. Okay. Let's see if this test is passing. All right, everything is passing. Let's review our changes. We are just calling this to test. And over here, I just have something that returns the current value. Okay. So maybe I could move this up. And then I can use it there. Just like that. And then over here, I think I should test the current value first. And it's back at 13. All right, no harm done. Let me commit the changes. And then now that we have this, I can comment out the circular buffer stuff. And I'm already over time, but I think that this will work relatively quickly. So let's see. We have a structure for circular buffers. Let's review this and then we run the test and see what comes out. So we have a struct for circular buffers that have an array and a circular counter. And then, oh, I didn't even finish implementing this. So to create a circular buffer, I have to have a size that needs to be positive, and I just allocate this. I initialize with a new array and a circular counter. Then to set a value, I set into that array, I step the circular counter in myself. And then to get a value, I have to check that the index is in bounds. And this is kind of overkill because when I do array get, it's already going to check the bounds for me. But I think it's nice to have this explicit. And then this is not just minus index. This is... Oh, I think I need an index variable here because I will have to do some shenanigans to the index. First, I need to get a hold of my circular counter so I can do this. Then I need to peek what is the current value in there. So I can use, where is it? Current value. So that's my index. Then I am going to apply, oh, I have index twice. I'll call this the array index. Then I have to add the index, which will be a negative number. This number coming in here is negative. So it will just work out. And I think I did it. I think that's the implementation. Yeah, let's see. This is crazy. Well, there are some tests failing, but the number of tests that is failing is changing. So probably there is something about this, the circular buffer itself that I'm doing wrong. I need some sort of reset in the beginning. Yeah, let's commit what we have. And yeah, let's have some sort of reset for the circular buffer. Bo is impressed. Are you deeply impressed with like this ridiculous thing? Yeah, I think it's mostly for the benefit of the test, but I think I need to have a reset situation. So let's implement one. And for this, I'm just going to set... Oh, hang on. Why do I need to reset? I am filling in the buffer as part of the test. Yeah, something else is going on. It's not that simple. You're too nice, Bo. You are too nice. And especially because you're saying that when I definitely have some problems with the code. At least the two last tests are passing, which means that something that we did is right. Yeah, if you just try to get these kinds of indices, at least that much is right. Oh, I think I know what the issue is. If my current position is like 1 and I subtract 5, I need to get back that value in bounds. So I have to apply a trick similar to this. Maybe I will have a function for this actually. I don't know, I guess I'll just hard code this for now. No, let's have a function for this. Yeah. Let's have a function for this. It needs to appear above because it will be used here. So I'll call this something like wrap, and I'll receive a value, a start, an end. Yeah, I think that's all I need. So let's go to where I have my while loop and copy this over, and instead of sign, yeah, this is gonna change. This is gonna change a little. Then value is what I'm going to return at the end. So I guess I'm going to keep the positive side of things. Even though things are not working, I want to keep positive. And naturally, my current value needs to change to just value in this situation. So if my value is more than the end, then subtract the range. What is the range? It is a local variable called range. That is the end minus the start. And let's have some tests for mathematical functions too. So maybe I'll just have a page that is not even called data structure, it's just called tests. And instead of page data structures, it will be called page test, and it will go up here. And I will have to do something like this. And Now, naturally, this order doesn't matter anymore, but I think I'll have it in order. Hang on, this doesn't make sense. Yeah, I think I made a mistake. Let's review these changes. Yeah, what the hell? Why did it move like that? There you go. And I think it makes more sense for me to have this first, so I'm going to move this up. There you go. Now, and I'm putting the tests first just because I want to just open the JSFX and see the test results instead of having to switch to the right page every time. And now I think I have more of these, like I have 5 of them, right? 0, well, it goes from 0 up to 5. So 0, 1, 2, 3, 4, 5. That is correct. And this was wrong all along, and JSFX just didn't care. So who knows? In any case, I think that this reordering is right. And instead of calling something like data structures. So see, this changed as well. This moved. And I find this weird. Very weird. I don't know what I did wrong, but I did something wrong. Okay, let's review these changes very carefully because something went wrong when I was renaming stuff. So I'm putting my tests page first. And then over here, I am testing for my test page first. And I'm calling something test and something tests. So this should be page tests. Then over here, I have my code for page tests. All right, okay. And I also have this new mathematical function that I have not tested yet. We'll get to that in a moment. I've got way more ideas DSP than the capacity to code them. That's true of all of us, Bo. That's true of every one of us. Let's see if everything is still working out here. I mean, yeah, it's crazy, but yeah, okay, at least the page change and everything, we're still having the same weird results. Now let's move on to writing a test for the wrap value. And I'm going to assert something about wrap. Let's see the definition of wrap. So if I have a value like 5 between 0 and 10, I expect to get back 5. If I have 0 between 0 and 10, I expect to get back 0. But if I have 10 between 0 and 10, I expect to get back 0 because it should wrap around. If I have something like 11, I expect to see 1. If I have something like 21, I expect to see 1. And if I have something like -1, I expect to see 9. I think that is right. We'll see. Okay, so we have more dots before the crazy stuff at the end. So wrap is doing the right thing, I think. Now let's use wrap instead of the while loop that we had below over here. And we'll have to be careful about how we wrap this. We need to take in account the signs to do the wrapping. Hang on. No, actually we need to have that whole logic of start and end being flipped here. Yep, wrap needs to be smarter. Let's copy all these tests and flip. Oh, come on. Just wanted to have some quick way to select everything, but okay, I can do this by hand. So if the range goes the other way around, then this is already at the end, I expect to wrap. This I don't expect to change. This is at the beginning, so I don't expect it to change. This is past the beginning, so I expect it to wrap around to 1, I think. Yeah, let's think about this. So 10 should be 10, 11 should be not 0 because 0 is the end and the end is not inclusive, so it should be 1. I think this is right. And then same for 20 for exactly the same reason. And then minus 1, well, it's actually 0 in this situation, right? That's already tested, so let's test 1. 0 should wrap around to the beginning, and this should go to 9. Okay, it's wrapping in the other direction now. And this is not going to pass. Right, it's not passing. So now we have to check if the range is negative or positive. So if my sign of range, or I will have a variable for this. Right, yeah, we'll end up writing code that is very similar to the code we wrote below, I think. And I think it's going to be great. So if my range sign, let's do this in one pass. If my range sign is negative, no, if it's positive, let's start with the positive case. But if it is negative, then we need to flip. And that's all there is to that. Let's test. A single failing test at the end. So it means that we just don't have the right value. Let's peek at what this is giving us and see if we like it and fix the test accordingly. What is this giving me? I'm going to peek now. It gives me 1. Do I like that value? Oh, 1 is between 10 and minus, it is between 10 and 0, so it should not wrap anything. I'm probably thinking about minus 1. And I'm not even going to pretend that I know what this is going to output. 9. So there you go, I was right to begin with. I am super smart, aren't I? Okay, let's double check the changes. And then we can use wrap. So now wrap is smart enough to work with backwards indices, which is super nice. So let's go to our CircularCounter and wrap. Over here, instead of doing this whole shenanigans with the step sign and everything, we don't even need the range. That has been implemented already. Oh yeah, everything is going to be a lot simpler in this function. We get a hold of the current value. We don't need to get a hold of the start and the end as special variables, and we don't need to get a hold of the step as a special variable either. Now, we can just add the step. To add this step, we copy this part. Then the current value will be out of range, so we wrap the current value using the start and end. Then we can get rid of most of this and just do that. Awesome. Yeah, let's see if the tests are passing. Yes, the same tests that were passing before are still passing now. Let's commit what we have and move on to here. All I gotta do is wrap the array index from 0 up to the size of this array. So L array size of array. Oh, and I already had that, so I guess I'm going to have a variable for this. Okay, let's rethink this. So I'm getting a hold of the array in the circular buffer, then I'm getting the size of that array, and I'm checking if the index is in bounds. If I have like number 5, let's think about this for a moment. I think I have the check wrong. Let's find where I have the circular buffer. So here we have the circular buffer, and I have some change. What did I change? That was a mistake. So if I have -5, my circular buffer size is 5. And if I try to get -5, that's already wrong. So my check should be less than or equal to. That's already wrong. If my index is already equal to the size, that's wrong. That's a mistake. So less than or equal to the array size minus the array size. So -5 in that case. Let's double check that we have a 5 there. Yes. So we have 5 slots. And then let's go to the tests for this to double check that the tests are right. Yes, 5 slots. Then I think that the error checking is right. Then I have an array index, which is just the index of, it's just the counter in the CircularCounter. I add the index that I'm interested in, and I wrap that with the array size, and then I get that position. Alrighty. So check this out. Let's commit what we have. And let's call this a day, shall we? I went 30 minutes over what I was expecting, but that was fun. I think it was a good stream. I'm happy with the results. We have a freaking circular buffer. Oh, that logic for wrapping stuff was not trivial for me. But I'm happy with this. All the tests are passing and everything. All right. Yeah. So let's do the usual thing to wrap up the stream. Go to my effects repository. Delete stuff from there. Get this. And copy there. And commit these guys. And push. That's all for this week. Thank you very much for your support. I see you back on Monday, and I will be with Arya over here, and we'll be working on his website, migrating a blog from Wix into a static website generator that we are developing ourselves. Super fun stuff. And I wish you all a great weekend. Thank you both for being here. Thank you, Arya, as well. Thank you, everyone else. And I get back to this project, the JSFX stuff, on Tuesday. So I see you there. Bye.